Good afternoon, everyone. You have made it to the final session at FireEye's Cyber Defense Summit. Congratulations. As you can hear from my voice, I've had a crazy couple of days here, so I'm going to try to keep this on track. And want to jump right into it, though. What do we want to accomplish today? By the end of today's session, I want all of you to understand what detection on demand is. We're going to give you some cool examples. We're going to show you some partners who are going to come up here and see what they've been able to do over the last couple weeks. We're going to show you some cool things with a Chrome plugin, and then a Slack integration that we just said, hey, let's just try doing it. So we want you to get excited about those. And then finally, maybe tomorrow, depending on your commute, maybe Monday, we want you to start using it. Go out, get the free version of it, and start building in your organizations. So we're super excited to talk about this detection on demand service. So let's get into it. Or now I can get into it. What is detection on demand? Very, very simply, it's a way for you to check your content to see if it has malicious check your files to see if it has malicious content. Very, very simple. That's all it does. How we do it and our technology that has been baked into our products the last 10 years are really, really complicated. It's the backbone of everything we do, and our engineer, Sai, is going to tell you how we do that, and it's really, really cool. But what we're excited about with it, because this has been the backbone of FireEye for 10 years, you now have access to our greatest tool. You can use it to check things in your SOC. You can use it to build it into your applications. So if you have internal development groups, give them this API. Let them post stuff to it. Or if you're a developer, you can use it any way you want. So we're truly excited about it because it's our first ever foray into a microservice like this. So I mentioned it, but you can use it any way you want, right? Detection on demand is malleable. Use it as you see fit. It could be in the cloud. You could use it for checking stuff on-prem. Use it any way you want it. We're super excited. Another thing, it's adaptable. I think you might have heard in the keynotes, we check 50 to 70,000 different pieces of malware per hour across all of FireEye devices. That is baked into this service. Everything we learn every single minute of every day is baked into it. So you're going to get the best results by using this API. And lastly, and again, most importantly, it's a cloud service. 99.9999% of the time, it works every time. That's what the cloud gives us, right? Always on. You can scale up. If you have a surge or let's say 20,000 files coming through your ecosystem, it can easily scale up to get that. So we're super excited because it is truly an on-demand cloud API that you can use any way you want to. And why is this important? There's a great article out there that talks about how microservices are the new enabler for innovation in a company. I think this is so awesome because FireEye, we're known for having great products. It could be your email, it could be your network, it could be your endpoint. It solves really big problems that you guys face every day. We are now giving you that one tool that you can use to solve all the other problems that might come across your ecosystem. Could be third-party suppliers. Could be people uploading public content from the internet. It could be anything, right? What we want you guys to do is go back home, talk with your teams, and try to figure out, how can I use this, right? Where am I vulnerable today, and where can I use this to supplement my protection? So we're super excited to announce it. As I said, it's the first time you can consume a service like this, and it's all via the AWS Marketplace. And we'll get into that in a little bit. And Sai's going to walk you through exactly how it's built, how it works, all that good things that if there's engineers out there, he's going to show you everything kind of under the hood. So with that, Sai is going to talk you through what happens when a file gets uploaded to the cloud. Sai?
Hey.
I'm not sure if that works.
Hey, thank you everyone for coming. This is Sai Vashisht. Yeah, before we go into this, let me share some thoughts. Like when I started my job at FireEye 6 years ago, my job was to maintain the detection efficacy of our products. As we know that threat landscape is changing each and every day. And every day, FireEye receive millions of files from the field, from different products. And it was very clear from the day one that manual approach never going to be scalable approach. So as part of our team, over the last several years, we have built multiple automation and detection system. And as part of that, like all those products are already in our FireEye product line. But one thing was like if somebody has to leverage those detection services, they need to buy the FireEye product. They can't just scan one file, or they can't scan their S3 bucket or their file coming into the team. So three main reasons were there that we started building detection on demand service. First was like how we can leverage all the automation and detection engine which we have built for FireEye product in the cloud. The second one was like how we can make it scalable, like it can scale based on the demand and it can scale up and down. Third was like single source of truth. Over the last decade, FireEye has collected ton of intelligence around the files, URL, hashes, all those things. How we can leverage that decade of intelligence as part of this service to provide a very simple answer, like when you submit a file to us, so that we can tell whether that file is malicious or benign. And along with that, we can provide you the context that why we think it's malicious. So as part of that, let's start like when a file is received by detection on demand, what are the life cycle of the file in the cloud happening? So it's a REST API driven services, like where we provide simple endpoint to submit a file. When a file is submitted, we look through our fast lookup. Fast lookup contain our decade of intelligence, our global services, where from we are gathering all the intelligence from a FireEye product. Along with that, the DoD detection on demand cache. If we already know about the file or the attribution or those kind of things, then the result will be readily available within like couple of seconds. If this is some new piece of malware like 0-day or we haven't seen it before, then it will go to the next stage. The next stage is engine selection stage. So now as part of the engine selector, we figure out that for this particular file, what kind of engine we need to invoke. It could be static analysis engine, which start from Yara, ClamAV, or it could be machine learning or AI engine. For example, like FireEye is building like malware guard, which help us in detection of PE file, where we extract a ton of features, and based on those ML model, we try to detect. Along with that, FireEye detection technology for malware, like dynamic analysis, that also is invoked as part of engine selection. So this is like FireEye bread and butter for all the product. Earlier, if we have to use the dynamic analysis engine, you need to buy our product. Right now, with the detection on demand, it will be readily available. So once the engine selection is done, that file goes to all the engine parallelly and being analyzed. After all the analysis is done, the results are collected as part of the correlation engine. And as part of the correlation engine, we built a model which consumed the feedback from the static analysis engine, machine learning engine, as well as dynamic analysis, along with the context which we are gathering from the FireEye intelligence. And as part of that, it is determined whether this file is malicious or benign. And it is pretty straightforward, like submit a file, in the end, you will know whether it's good or bad. So architecture is pretty straightforward. We have built everything natively on the AWS. 95% of the architecture is using microservices and serverless in order to run Yara, ClamAV, and machine learning engine. And our dynamic analysis technology is running as part of AutoScale group, which can scale up and down based on the demand, and definitely backed by the FireEye threat intelligence. Let's go into the demo. Yep. Okay. So detection on demand is readily available in the Amazon marketplace, where you guys can go, select your plan, click on subscribe. With a single click, you will be able to acquire this subscription. So we are also offering the trial plans where you guys can buy a trial plan and acquire it. The next step is you need to set up the account. For me, I already set up the account. Once the account is created, a interface will be provided to you where one can go and create the API key. And once the API key is generated, it's pretty straightforward. We are providing the documentation around the REST API, that how this key can be leveraged in order to call these APIs. And we also providing different connector in order to scan your files. It could be S3 bucket scanner or Slack channel, which Chris will go over shortly. So we copied the key. There is a Swagger documentation which provide all the endpoints, that how those can be invoked and what kind of parameters they take and how you guys can retrieve the report. And let's go through the Chrome demonstration. This is one of the examples that how these APIs can be leveraged in a simple to use workflow. For example, like you are a user and you have a file, you just want to figure out what FireEye knows about it. So user need to install this Chrome extension, and once that extension is installed, user would have ability to upload a file, check the history, and see what FireEye knows about it. So let's upload a file, and this is a malicious exe we uploaded. FireEye generated a transaction that there is a successful submission. And if we go to the history, it's already being detected because FireEye already knows about it. And as you can see, the duration it took to analyze the file is in milliseconds, so that's why it's shown 0. But when you click on Get Extended, it's going to provide you all the information associated with that attack, like what kind of attributions are associated with it. Is it an APT attack? Or what kind of process, network, registry activity that sample is doing. So all that is captured as part of this JSON information. So let's see, like if it is, we consume it as a HTML, how it's going to look like. So this is like malicious file. It's going to share like what kind of malicious activity we have seen. Like we have seen exploit activity where malware is running shell code in order to execute something. Then it has VBA code, it launching the different process, doing code injection. And in the process tree activity, we will be able to see that what kind of process it is launching. For example, like it's a WinWord, it's a document file, went to a WinWord, launching a CMD, and CMD launch another CMD, and it's launching a PowerShell. And then finally, after PowerShell, we are seeing the final payload, which is doing CNC activity. So this is kind of like the high-level overview that CNC and Nectar activity, all those will be provided to the user when they submit the file. So this is kind of like one example. Another example could be you search a blog post, and that blog post has some hashes. Yeah, it happens. Yeah, blog post has some message, and then you guys can click on the same Chrome plugin. It's going to scan the page for all the hashes, and it's going to call the backend of detection of demand services to figure out what we know about this particular hash. If there is a hash which is malicious, it will be labeled malicious, and if user click on that, they will receive same amount of information like is it a APT attack, when FireEye discovered it, and along with that, it's going to provide all the information associated with that if you say get extended. Yeah. So this is kind of like pretty much it. Chrome is just one example. We have built other integration where companies can share their S3 bucket, and it can scan all that bucket depending on the number of files over there. And there are like ton of example or use cases of how this service can be leveraged. The whole idea was like easy to use and easy to integrate, so that whatever use case end user have, they can leverage these services and start figuring out whether they are dealing with the malicious files or not. Okay, so I will call up Chris again for the demo for Slack channel. Yep.
Cool.
Awesome. Thank you very much. Yeah, thanks for staying late. Yeah.
Cool. And Saya is also being really modest. Just a couple months ago, he had this idea to put it out here, and within 3 months, he was able to make all of this happen. So amazing job of getting this out there. in its current format. I met Sai about 3 weeks ago, and I was really inspired. I said, man, I wish I was a developer like Sai. I wish I had his technical chops. I really wish I had his hair. It's amazing. And so I said, well, let me try to do something, right? Let me try to be a developer for a day, right? My bosses didn't really want me to spend much more time than that on it. But I said, I think I can build a Slack integration. And I don't know if anybody ever used a tool, Zapier? Ever hear of it? Okay, a couple hands. But it's a tool for non-developers. You have to do a little tiny bit of coding, but it's an easy way to develop. So what I'm going to do is I'm going to post a file to the Slack community here, and you can tell I'm not a real developer because I'm doing a live demo, which shouldn't ever happen. But let's assume that I am for a moment. And I'm going to upload, I just got out of my Agile meeting. I'm going to upload my feature request plan that I had, and I'm going to put it in here to the Slack channel. So it goes up there, and first thing, you see FireEye detection on demand say, hey, we got a new file. Let's go check, see if it's malicious or not. And while it's doing that, I'll take you into the Zapier page. And what this does, these are all the integrations that I was able to build. All of these were built in less than 1 hour, which in my mind, I'm like, how did I do this, right? I don't know if I just kind of blacked out for a while and I woke up and all these integrations were here, but I was like, wow, I did it. But I have Slack integrations, I have Box, I have Gmail. You can do 1,000. If you use Salesforce, if you use different types of collaboration tools, anything that you use in your, especially SaaS products that you use today, you can find them through this. And what's really cool is that when you come in here, it walks you through the steps. Like you can do whatever you want. And the way I had set mine up is I said, whenever a new file comes into Slack, I do a little message to let people know it's there. And then this is probably the only technical piece of it, is I had to write to the API. So I had to put the API in here. I had to select the file to send to it. And it's a really easy user interface. Was able to send it up there. Probably took me about 30 minutes to do this piece of it. But what's great is we have that documentation now. Jordan's going to talk about how you can go get that, so you don't need to spend 30 minutes on this. You can spend 5 and be up and running. And then you have to wait a little bit, right, depending if it's a couple seconds or maybe a minute to get the result. You get the result, and then you do something with it. What I'm going to show you is just a very simple result to show you what a malicious file would look like. But you could do 100,000 things with this. You could send a text message to your CISO every time a file is uploaded to Slack. He probably doesn't want to know every file, but it could be an example. You could send an email to your security center. You could delete it. You could move it to a quarantine. All of this is at your disposal. So it's really cool and really easy to use. So let me go back to Slack. And luckily, I was talking long enough. And now you see that evil has been found. Please report it to your nearest security professional. Please stop doing whatever you're doing. But you can customize this to your heart's content, right? And you can do this across so many different things. And that's the power of the API, right? That's why it's really cool to work with someone like Sai, who can develop something so amazing that even somebody like I, who run partnerships, can do. So Sai, thank you for all of your work. So awesome. So that was my example. If you have any questions, afterwards, please come see me. But then we said, okay, if I can do something, imagine what somebody who actually has some development chops and can do integrations with our products that we work with every day. And that's what I wanted to bring up Paul from Corelight to talk about. How he was able to do the integration with his team and scan a lot of different files coming through the network. And hi, Paul. Let me get your presentation back up.
Chris.
Thank you, sir.
And hopefully this works. I will use the clicker if it works for me. Exactly. Folks, hi, my name's Paul Bartroff. I'm one of the engineers at Corelight. We want to definitely thank FireEye for bringing us in here, giving us a chance to tell you about who we are and how we were able to work with FireEye for this specific instance and how we integrate in general. So if you don't know anything about Corelight, I will just give you a brief introduction to the company, and it looks like we will not be using the clicker either. First and foremost, for those of you that are out there, oh, it goes too quick for me, is that Corelight Sensors, we have a network traffic analyzer. It's in the network security monitoring space. But the platform itself is really built on top of an open source technology formerly known as Bro, now Zeek. Matter of fact, our open source conference is going on right now in Seattle. So we too are running around crazy with our own event, if you will. So these sensors, though, that were built on top of Bro in itself, since that's the background of the technology, and we are an enterprise platform versus just a tool in the open source community, to talk a little bit about what is Bro or Zeek. This technology was built in 1995. It's not even a new technology. And Vern, this gentleman on the screen, worked at Lawrence Berkeley National Labs, where he's trying to solve a very complex problem, getting some visibility into the network space, trying to understand protocols, protocol misuse, et cetera. And we labeled this, or he labeled this, I should say, as an IDS. And at the time, maybe it kind of fit a little bit better, but fast forward to today, the technology is still relevant, and it gives very rich network metadata inside an organization. And it's linked metadata, so you can actually pivot and move in between fields. So as an analyst, you can really get a good understanding of what's happening inside of your environment without having to go really, really deep in the actual packets or event information that you might see. So those are the folks that know absolutely nothing about Bro. But what's really interesting is I said it was long in the tooth, right? It started in 1995, and today we're pretty far down the line. But the industry has already accepted the technology as sort of the de facto standard with respect to network metadata. It's evidenced by many companies building the engine into their commercial platform. Somebody, I think, that was at Mandiant developed Security Onion, if I'm not mistaken, and Security Onion has Bro installed in it. Rock NSM. There's commercial offerings out there that have the engine inside of it. It is recognized as that flight recorder, if you will, for network metadata. But it's really a data generation platform, right? We're generating data, enriched data, linking it together. And we want to focus on that as a data-first approach. We want to enrich the information versus a lot of other technologies are trying to take the analysis approach, like coming up with new ways to analyze the data. We're trying to come up with better ways to provide new and enriched data so it can be analyzed. So it doesn't have another pane of glass. It doesn't have any more widgets or buttons or anything else. It's really producing this information for your analytic platforms. So when they created the company, or Corelight, they founded this initially on like a supportability aspect of Bro, open source technology. And come to realize that you spend more time troubleshooting other people's stuff, like operating system information versus your actual platform. So these three faces you see in this magical fourth one are the principal contributors to the Bro project. So even though the technology as an open source technology has been implemented across many different companies, platforms, services, et cetera, these are the four people that are really committing that code to the actual package. And they are all the people that are supporting that here at Corelight. So when we think about Corelight as an enterprise platform, we're talking about scale and data into an environment for analysts. This is the data types, if you will, because we're providing protocol information and how it's linked, and we're sending this upstream to an analytic platform. And one of those analytic platforms is Helix. So we did some Helix integration with our actual data set before, so we're bringing in new relevant network security and network traffic analysis data sets into Helix that can be applied with all correlation information and hunting capabilities. Now, we have this integration in the native sense from an enterprise standpoint, just like with the enterprise technologies that I've deployed, is that FireEye's capability has been around for quite some time, sandbox technology, very good sandbox technology. We extract files on the order of 12,000 to 20,000 objects a minute, which is a lot of objects that you can extract out of the protocol. And we can take that information, and we could have traditionally dumped that information into an AX, I believe is the current name of the platform. But we would still be sending that log data into a log aggregation service where you can take that information. The Helix platform was giving you the ability to get that data back out from the sandbox as well for more correlation. So talking a little bit about integration, though, in the cloud. So we also have cloud-capable products. Amazon, earlier this year, say July timeframe, can't recall the actual month, released their network tap that's inside the cloud. And that gave us the ability to build our product and take a mirrored traffic from inside of VPC. And then we can do the same thing again and send that information into other log aggregation services, sandboxes, et cetera. So this platform works in different form factors, if you will. Why does that keep happening? Okay. So from this perspective, our integration up to this point has really been around Helix and the existing FireEye technologies. But what made it so interesting and neat using this detection on demand service is that we can easily perform that same task using that service for the extracted files. We can do the same thing. We can send all of our files and objects that fit 12,000 to 20,000 objects per minute, potentially into the detection on demand service via S3 buckets, where the service then picks it up, executes the information, and then can even couple that back into the Helix platform. And in a nutshell, that's how we put the integration together, and we were able to work with FireEye in such an easy and fast way. With that, I'll hand it over to Jeremy.
Hi, everyone. It's working now? Yep. Awesome. Okay. Let's back up a second. That does. Go back here. Hi, everyone. My name is Jeremy Fong. I'm Senior Director of Product Management at Accellion. I've been at Accellion for about 5 years, and I'm responsible for platform integrations, platform services, and data analytics. So I'm also part of the team that led the integration with FireEye Detection on Demand. So what I'm going to do is spend a couple of minutes just telling you about Accellion, who we are, what we do, and why this integration was so important for us. We are a company that helps enterprises mitigate third-party risk and maintain a zero-day trust policy, the organization. And we do this by allowing them to send files securely from the inside, so inside the organization, to the outside world through sharing and collaboration, and also bringing that content back in on-prem into the organization through the firewall. So you can think of us like a content firewall. We wrap that content, we securely encrypt it and decrypt it in transit and at rest. We've been around for about 20 years. We have many customers in the enterprise industry, heavily regulated, and they're across the world, all over. Here's a list of some of those customers. As you can see, they're all heavily regulated in pharma, healthcare, so they're sending medical records and different things, PI, PHI. We have government customers, financial. The list goes on and on. And so if you can imagine, we have the heavily regulated, let me see. It's a little bit out of order here. About that. Okay. So you can imagine our customers who are heavily regulated, compliance is a big deal for them. So this is a list of our compliance standards. So in healthcare, there's HIPAA, in financial services, there's SOX. And in government, we're the only vendor that provides a FedRAMP compliance in our space. Now, this is a picture of the organization, a typical organization. In the center of this circle, you can see that there are enterprise content sources. So you have content sources that are on-prem, they're cloud sources, like OneDrive and G Suite. And so our product, we don't care. So we can actually go into these sources through our content connectors, grab these files, and allow users to share these files with the outside world. So we deem the center part of the circle as a source of truth, or what we call the system of record. Now, for the purposes of FireEye, content coming in is also important for us. And so the content coming in also needs to be brought in securely. But not only that, it needs to be scanned for antivirus and malware and ATP, as we kind of mentioned in the previous presentations here. So let's see. It's jumping around a little bit odd. So let's go to this. So in our demo, so what I'm going to show you in this demo video is two scenarios. So actually, there's a setup here, and then there's two scenarios. One is when a user, a third-party user, comes in and wants to bring a file in. So imagine, a patient wants to share, maybe the medical records, or they want to maybe share some of the personal information with the hospital. That content coming in, that file is getting uploaded, or those files, that payload gets uploaded, and what we'll do is we pass that to FireEye. FireEye will then give us the decision, the verdict back, if it's benign or malicious, that we've been talking about before, and then we'll act upon that. So if it's benign, we'll let the file go, and that content can be shared within the organization. Of course, if it's malicious, then we'll quarantine that file, and we'll basically put it aside. We'll notify the security admin and to let them know that they need to take some action. Also, in this process, we maintain a secure audit trail. So I didn't mention this before, but this audit trail or that data stream can also be pushed to Helix. So we also have the Helix integration. So you can push all that data and do more analysis through Helix and look for anomalies and different things. So if this plays here, I'm going to play this here. And so here's how you set this up in our admin console. So this is the web app, and this is the admin console. You go in, you add the security scanning here, FireEye detection on demand. There's a bunch of settings here, but it was really easy to do. So you just add the API key, and you add the host name of server, and you're off to the races. Now here in this demo, this is the first part of what I explained, where the end user or the third-party user will upload the file. In this case, it's benign. We marked it benign to make it easy for the demo. And this will go through to FireEye. FireEye will quickly return a response. And in this case, it's benign, so it'll just go through. And so in the UI, it's already shared with anyone in this group or in this folder. So here's the admin. So on the back end, most of the stuff is happening on the back end, as you can imagine. So on the admin side, you can see that the verdict here, see FireEye on demand, ATP, benign, down there. Now the second case, the third-party user now uploads the file, but this is malware, named malware.exe. So we upload the file here, and just as quick as the last time, that file is sent to FireEye, and we get a verdict. In this case, the verdict will be malicious. And so what we'll do here is we'll hold the file, as I mentioned before, we quarantine, and basically notify the security admin knows. And here in the admin, you see malicious quarantine by service. And so we take that away. On the end user UI, what happens is that the files, it's there, but it's actually not clickable or viewable or downloadable because we just hold it. Now, for purposes of our story and the organization itself, we want all of the content to go through our service. So we have integrations with Salesforce. We have integrations with legal connectors like iManage. We have Outlook and Office 365 integrations. We have plugins. So all these files, all of these integrations are used to move this content in and out of the organization. And the reason why this is important for us to integrate with FireEye is so that all those files go through FireEye and go through scanning as well. So we get some sort of verdict, so the organization is protected. Let me scroll through here. Now, here is just a code snippet of what we did. And it's pretty straightforward. It's Python. And if you look at line 45, that is the call where we made to just submit the file. Pretty straightforward. And then lower down in the code in line 66, this is the area where we basically ask what the verdict will be. And this is very easy, and Jordan and I even had a talk, and there's ways to even make this easier, but really it's 2 calls. And there's some code here that basically talks about the error handling in here. But mainly, this is very easy. It's kind of an example of what this looks like. So most of the integration was our logic, how we handle errors, waiting for a response, the timeouts, and different things. But in this case, it's 2 simple calls. Very easy. Quick. So just in closing here, reduced development time. So we actually did an integration with AX, so the on-prem solution, the hardware, and it took some time just to get the hardware and get it set up, and but once you start working with the APIs, they're pretty straightforward as well. Now, this integration that we did, talk about reduction in development time, was extremely fast. we basically decided that we wanted to do this. We already had some of the logic because we already integrated with AX. So it was really as simple as using those 2 calls to integrate. So it took us less than half a day. So when we talk about ease of use of the APIs, getting the documentation is super easy. Now, secondly, this integration was very important for us. We were talking about securing content going to the outside world and content coming back in. On the way back in, that's when most of those risks occur, right? Is somebody clicks on a file, something happens. So holding that file until it gets scanned by ATP and then getting a verdict is essential for us in our integration. So we are a platform that can extend to security scanning, and this was perfect integration for us in that way. And lastly, I'll mention the flexible deployment options. So we have AX, which is on-prem, then we have Helix, right, that does a SIEM, and then we have hosted now. So now we can offer, for hosted customers, fully hosted, we can offer hybrid, or we can offer on-prem with the AX system. So it really completes our story in such a way that we have all the deployment options that we can give to customers. So that's it for me, and I just want to thank FireEye, and it was really fun and exciting to do the integration with them. Extremely responsive. We were just talking in the hall about how easy it was to work with the APIs and with the team and all of that. And so if you have any questions, here's my email. Feel free to reach out to me about the integration or about anything else. And I appreciate your time. Thank you. Thanks for staying.
She's going to have you come back up. Hey everybody, my name is Jordan Violet. I'm the Developer Relations Manager for FireEye. If you were in Grady's keynote on Thursday, he mentioned my name a few times. You might have saw the announcement for FireEye's new developer hub. So it's my team's responsibility to make it easier for all of you to integrate with the products that FireEye has today and the products that we have going forward. So when they talk about the ease of integration, they weren't kidding that we just dropped this in their lap about 2 days before we were about to head out to DC, and we said, hey, we just made this really cool API, which just made about a month and a half prior at the time. And we said, is there anything you guys can do with it? So I wanted to come up here and, how easy was it? But I didn't really want to stage that for you guys, So what was it like having this particular API dropped in your guys' lap last minute?
So from our perspective, we had a pretty easy integration with them to begin with, but it was our platform itself, again, being that it's a technology that is a data producer, just finding some way to actually integrate with the technology by taking those objects themselves and giving to them was facilitated through S3 buckets. So that was somewhat of a native integration for us. Working with the team, it happened pretty quickly. There's actually a demo too that we have. It's a video, I believe. I think Grady might have actually showed it at the keynote. Did. So it was a very simple integration from our perspective. I think it was even much simpler than probably yours. You had 2 calls. We probably just gave access to an S3 bucket. So I guess the short answer here is that it was a very simple task, and it was dropped in our lap very last minute.
Yeah, no, it was very last minute. We had a call like Friday afternoon. So how did you guys get help for that API when you needed help when you were using it?
From our perspective, we were using the Slack channel with the team from you guys, right?
Perfect. What about you, Jeremy?
Yeah. So the first question I asked, about the ease of use and different things. So, the longest pull in the whole process was actually the business side. So, Lorraine's actually sitting back there, and she's our VP of Business Development, and so she's facilitating a lot of this relationship here. And it was really kind of talking about, okay, well, when can we do it? Can we fit it into our development cycle? The coding itself, as you can see, it only took, I'd say half a day, but really it probably took an hour or so to actually write the code, because we had the business logic already built in because of the AX integration.
These guys are being very generous and giving us some content up here today, because when I asked them earlier today, they said we didn't need help. The API docs had everything we needed. So I appreciate that.
The help question definitely, it was maybe 1 or 2 emails where we said, oh, here's the API key. And so you saw the API key in our admin. And pretty much we were off to the races. Once we had that, we can call the APIs, and it just worked. So there wasn't any dialogue at all. Even we're using the Slack chat, but there wasn't really any dialogue about it.
Do you guys have any advice out here for the people who may be interested in using it?
I think one of the premises behind going to these services, like Sai explained how they built on top of microservices. Now, we're not standing up here, and I'm not at AWS telling you this, but The reality is organizations are putting things together. You want to build your own solution. You want things to work a certain way. So this is facilitating some of that capability because you might have your own internal applications that you build. You might have your own processes, business processes, logic, which can be both integrated with both technologies from their perspective and from FireEye's, is the ability to take that application and add a layer of dynamic analysis into it. And well, I guess I shouldn't say dynamic analysis because you have like 3 or 4 engines that are part of that system. So I think my recommendation is that you should be able to get out there, play with it, see how it could fit into some of the logic or steps that you might take when you're building your own application or you're adding a security layer to that application.
What about you, Jeremy?
Yeah, I mean, I would emphasize the logic as well. The business logic was the biggest part for us. So, you know, we don't use ATP going out. We only use ATP going in, right? So we use things like AV and DLP going out to kind of make sure that files are not getting sent. But when files come in, that was the part that we were dealing with, is more on the business side versus actually using the APIs. I've done several different integrations, worked with different teams, a lot of different platforms. You know, this documentation was really easy. And so I don't have any thoughts on that.
Oh, very cool.
It's just,
well,
I know that there's an SDK coming out, too.
Yeah. So something we're going to talk about here. Thank you guys very much
Okay.
for taking the time to integrate with us in such short time.
Thanks.
Give them a round of applause for doing something in such short notice for us. So like Jeremy was talking about earlier, the purpose of my team is to provide the resources for you or your developers to get integrated with our products faster. So as Grady announced on Thursday, we launched FireEye.dev. So we have a developer portal where developers can find all of the guides, API docs, and then additional technical resources. So one of the things we provided, we just couldn't get it to Jeremy fast enough because they integrated truly so quickly, is we started a Python client library for the detection on demand service. So that line 44 to line 68 ends up becoming about 2 lines of code, and you're sending and receiving data to the detection on demand service. Thank you.